Hi everyone, welcome back to our Mist AI-driven SD-WAN configuration guides series of videos. My name is Shai Donovich and I'm a solution architect here at Juniper on the Mist AI-driven enterprise team. And this is going to be section 5 of part 2. That's going to be a quick video. We're going to look at how do we enable or create steering profiles and policies to enable local breakout traffic to the internet from the LAN side via the underlay networks. And with that, let's get going. So looking again at our first example where LAN 0 on the spoke is sending traffic towards hub A LAN 0 over the VPN IPsec tunnels. But indeed also we want to allow traffic going to the internet via the underlay network 1.0 and 1.1, what we refer to as local breakout from this LAN 0 towards the internet. And for that, we would need to create an application, quad 0 in this example, or it can be any other destination, not necessarily custom app, but it might be even Zoom or any layer 7 applications. And we would also need to create a specific steering profile for that to direct traffic towards the underlay instead of going overlay towards the IPsec tunnels. Okay, so looking at this spoke LAN 0, we can just to identify, we can clearly see that our intent is to direct traffic to the underlay, going to the internet through my lab firewall. And really what we would need to do is we need to have a policy on our spoke template or one edge template that would direct the network or any traffic coming from spoke LAN 0, 10.0.10/24, going to an application. But in this case, the application is inetall, which is going to be quad 0. And this application is resides on somewhere on the internet, right? And not on the hub or over the VPN as we have previously configured in the last video. So in order to do that, the first thing we would need to do is to create this application. And in this case, I'll name my application inetall, stands for internet all, and I'll just include the default quad 0.0.0/0, essentially saying anything that you are trying to send to anywhere, it would go towards the local breakout going to the internet. You may ask, well, I mean, we have another traffic that already going to a specific IP, which is this 10.0.100.1, as we configured in the previous video. But that's okay because the way we'll manage the security policies on our SRX would be first diverting this traffic from LAN 0 on the spoke to the hub. But then the rest will go to the internet. So really, if we take a look at our one edge profile here, after creating this application, we will go ahead and we'll open again the one edge template for spokes. And we will configure an additional steering profile, very similar way. We'll name it to inet_LBO, just to make sure we identify where are we going to be diverting our traffic towards the internet. And again, I'll show you in subsequent videos that we can also do breakout to the internet through the hub. There are some cases that you would want to do that as well. This is why I'm mentioning in my steering profile that this one specifically is referring to LBO, local breakout, on that spoke device. And the strategy is going to be ordered, and I first want to use WAN 0 as my primary link, and if primary link fails or degraded, we're going to switch to WAN 1. As an example, WAN 0 might be my broadband link, and DSL or cable, and then WAN 1 might be my LTE link as a backup, and I'm not sure I'm gonna use my LTE for traffic if my broadband is intact. So That's why my strategy would be ordered: first use WAN 0, then use WAN 1. And similarly to our previous, the way we configured application policies in the central repository, we'll go ahead and we add another policy named spokes LAN 0 to inet all. And the network would be again spokes LAN 0, inet all is the application and allow, and then we're gonna follow the same process of importing this policy into the 1H template for the spokes, and just applying the steering profile that we have configured. So with that, let's switch to Mist UI, and I'll show you how to configure this. Okay, so the first thing we want to do is we want to add this additional application to our applications list. We click on applications and then add applications, and we wanted to call it inet all, and we would include our default quad 0 as a custom app. By the way, I mean, if we would like to specifically direct traffic to specific destination, we can always pick from the list of layer 7 apps that we support, as an example, Zoom or other things. But I'll cover this in a different video when we'll discuss on regarding web filtering. So for now, we can click on add, and the application has been added. The next thing we want to do is we want to navigate to our application policy, which is our central repository for all application policies that will be then imported to different profiles and 1H templates. And here is where we have the previously two created application policies already to direct traffic to VPN and from VPN. And we can then go ahead and click on add application policy. I wanted to give it a name, and we wanted to name it spokes LAN 0 to inet all. And we can then go ahead and pick up the network, which is LAN 0 on the spokes, and then the application that we have just created, inet all, shows up here on our application list that we can pick from. Click on done. And we can go ahead and save this policy. The next thing we want to do is we want to navigate to our 1H template for the spokes. Click on spokes. And we can see here we have our previously created two steering profiles to direct traffic to VPN going to the hub, and from the VPN going to spoke LAN 0. And here's where we can go ahead and click on add another traffic steering, add traffic steering. And we're gonna call this traffic steering to inet underscore LBO, local breakout. And then we're gonna add the different paths to this traffic steering. And obviously it's not gonna be an overlay, but there's gonna be an underlay WAN. And you can then select how many WAN links you wanna have in this steering profile. In my case, I do want to have both of them, both 1.0 and 1.1, that would be acting as the first preference is going to be 1.0 because my broadband is an example, and then fail over to WAN 1. And we can go ahead and click on add. And here is the additional steering profile has been created. And now we can use the application policy we have configured as import application policy. And you can see these two are grayed out because already included in this 1H profile, and the only one that we can select is spokes LAN 0 to inet all. So we're gonna click on import, and then we're gonna select here our steering profile that we just created to inet all via local breakout. And as we can see here, basically the three policies that we currently have configured. The first one says spoke to hub LAN 0, which means the specific prefix that we would direct towards the VPN. And then we have spokes LAN 0 going to inet all, which is picking up the default. Anything other than 10.0.100 .0 would actually use the local breakout towards the internet. And with that, we can go ahead and click on save to save the profile, the template. And once this template has been saved, the configuration is always instantly pushed to the device, to the spoke, or actually to all spokes, depends how many spokes you have. But for now we have only one, but we will be adding the additional sites. So any configuration you do here, they're actually going to be pushed to all our spokes. And we can quickly switch to the device just to see what is the application policy or security policies that have been configured on the device to allow traffic to the internet. So looking at our site 1, which is our spoke device, we can look at the additional policy that has been created here. And as we can see, we have spokes LAN 0 going to 10 zone, picking up the prefix 10.0.10 going to any address, any application. And same, we have a policy created for when 1 going to LAN 0 going to when 1 as well. And so we can then quickly ping 10.0.101, which again the hub, and we can see we can get across the VPN, and we can also ping 888, and we can see now that we have connectivity to the internet as well. And we can also look at our spoke device by opening an RDP session to the device. So previously we were able to get the page on LAN 0 of hub A. And if we open a new tab, we can also see that we have connectivity to the internet. So that means that we have connectivity to any application or any destination as we have configured. To miss.com as an example, you can browse the documents. By the way, there's documentation under SRX, and you can hear there's a design guides, and here is all our video series as well, where you can browse from here. Also, just a quick note on SourceNAT. Since we are going local breakout to the internet, if I go back to my 1H template for the spokes, I can see here 10 and 11. And as a reminder, when we configured each one of the WAN interfaces, we have selected, or by default, the selection is to do SourceNAT by the interface. We'll discuss in a later video on how do we have the other options to configure NAT for pool NAT as well. If you have different range of public IPs that you want to use for your source NAT. But again, for now, it is configured as source NAT via the interface. And so if we switch back to our device, we can look at the NAT policy that has been configured as well. And we can see here that we have a rule set that is basically picking up spokes LAN 0 to WAN 0, and this is allowing source NAT interface to be used when going out to the internet. So again, this is just a quick note on that as well. Okay, so with that, we have completed our first use case, and now we have LAN 0 on the spoke. Traffic is enabled to reach the hub, as well as going to the internet via local breakout. Okay, so next, what we want to do is we want to add site 2 and site 3. And so we'll have LAN 0 in all 3 sites. And as you would probably figure out, we would need to use variables. This is where I'll introduce you to the way you use variables with Mist. That's in order to have distinct segments here per our use case here. You know, site 2 is going to be 10.02 and 10.03 in site 3. In order to do that, by using one single template, which is our spokes template, we would need to define the network a bit different using a site variable and also a mask variable as well. And so I'll show you this in the next video. So with that, see you in the next segment. Thanks for watching.